Hi there and welcome to a video where I go through all the past paper exam questions for Edexcel Core 3 that have come up involving the Rcos theta plus alpha method. Obviously this is the same for the R sine theta plus alpha method, but I've just called it that title for simplicity. As always, try a question by pausing the video and then watch my answers and write them down carefully, noting any differences or corrections you need to make. Okay, here's the first one. Okay, so I'm going to do part A first. Part A asks us to express the following in the form r cos x plus alpha. As always, I ask you to write down that 5 cos x subtract 3, we are trying to write that in the form, subtract 3 sine x. We are trying to write that in the form r cos x plus alpha, and then you expand this out and you would get yourself r cos x cos alpha subtract these double angle or addition formulae are given in the formula booklet, r sine x sine alpha. Okay, and that was 5 cos x subtract 3 sine x. Okay, therefore you can compare and you can say that 5 must be equal to r cos alpha, and you can also say that 3, because we've already got the negative sign's fine, 3 must be equal to r sine alpha. So you write your two equations down to state that, i.e. 5 is equal to r cos alpha and 3 is equal to r sine alpha. Okay, and then you can, as always, to get r is always the square root of these two squared and added, 3 squared plus 5 squared. So r is the square root of 9 plus 25. So r is going to be the square root of 9 plus 25. R is going to be the square root of 34. So that's r. As always as well, you can write down that tan alpha must be, it's this equation divided by this equation, so tan alpha must be 3/5, and therefore alpha must be the inverse tan of 3/5. And we're working in radians mode, so put your calculator in radians mode and you work out the inverse tan of 3/5 and you get the answer 0.54. So alpha is equal to 0.54 radians to 2 dp. So state your final answer then. Therefore, I would write this underneath. I've just run out of space. 5 cos x subtract 3 sine x is therefore equal to the square root of 34 cos of x plus 0.54 radians. And that's your answer. You're done. Okay, let's move on to the next part. Part B. Hence or otherwise solve the following equation. We're always going to do the hence way. Hence solve that equation. Solving that equation is the same thing as solving the equation the square root of 34 cos x. And what did we find for this? Plus 0.54 plus 0.54 is equal to 4. Okay, it's equivalent to that. So how would we solve this? Divide both sides by root 34. So cos x plus 0.54 would be 4 divided by the square root of 34. Okay, and therefore x plus 0.54 would be the inverse cos 4 over the square root of 34. Okay, tap that in your calculator, calculate in radians mode the inverse cos of 4 over square root 34, and you should get yourself 0.81. So x plus 0.54 is equal to 0.8148 radians. So okay, at this stage you found x plus 0.54 and you found it's 0.81. before you race ahead and just solve this, you had better check if there are any other solutions in the range 0 to 2 pi. So draw yourself out a cos graph. A cos graph looks something like this. Okay, this point here is pi by 2. This point here is 3 pi by 2. This, sorry, that point there is pi, and this point here is 3 pi by 2. Okay, so you've got 0.81, and 0.81 is somewhere here. So there'll be another solution over here, i.e. 0.81 back from 2 pi. So there's another solution for this, which is 2 pi subtract 0.8148. So therefore, x plus 0.54 is equal to 0.8148, and 2 pi, take away that, so 2 times pi subtract 0.8148. The other solution is 5.468. So then to get x, you subtract 0.54 off both sides, so you get 0.8148 subtract 0.54, you get yourself the answer 0.27 radians, the first one, and you get yourself 5.468 subtract 0.54, and you get yourself 4.93. So 4.93 radians, and you're done. They're your answers to 2 decimal places. Okay, next one. Pause the video, have a go. Okay, going through this, let's go through part 1a. Express this in the form Rcos theta plus alpha, where alpha is between 0 and 90. Okay, I'm going to straight away, I can start doing these quicker. I can say 12 cos theta minus 5 sine theta. Expanding this out in one go, knowing my addition formula, which is given in the formula booklet, that would be r cos alpha, sorry, cos theta cos alpha, subtract r sine theta sine alpha. And by equating, I can see that 12 must be the same as r cos alpha, and I can also say that 5 must be the same as r sine alpha. So I can write those two down, write them down to get a mark. 12 is equal to r cos alpha, and 5 is equal to r sine alpha. From that, as always, r is therefore the square root of 5 squared plus 12 squared, and r turns out to be 13 when you work that out. And also, tan alpha is going to be 5 over 12. So alpha is the inverse tan of 5 over 12. Tap that in your calculator. This time your calculator in degrees mode. So inverse tan 5 over 12. And you get yourself 22.6. So alpha is 22.6 degrees. Therefore, write your final answer. You can therefore say, quite easily, you can say that therefore 12 cos theta minus 5 sine theta must be equal to 13 cos of theta plus 22.6 degrees, and you're done. Okay, right, time to do the next question. Hence solve this. Okay, we're going to obviously use the hence bar. Have we seen 12 cos theta minus 5 sine theta before? Yes, we've just worked out an expression for it. We've just worked out an expression for this, and we can use that instead. So the expression we worked out was that this thing is equal to 13 cos of theta, and I think it was plus 22.6 plus 22.6 degrees is equal to 4. Easy to solve. Divide both sides by 13. is equal to 4 over 13, and get your principal value, theta plus 22.6, by taking the inverse cos of 4 over 13. So your inverse cos of 4 over 13, 72.1. So theta plus 22.6 is equal to 72.1 degrees. Now don't race ahead and just subtract 22.6 off both sides. Do check if there are any other answers that are valid here. We're drawing the cos graph here. The cos graph looks something like this. Are there any other values that this could be? If 72.1 is a value, is there anywhere else you could get a value between 0 and 90? No, there isn't, so that's fine. So just subtract 22.6 off both sides, and you get yourself 49.5 degrees. 49.5 degrees, and you're done for that question. Okay, in the last part, solve the following. For theta between 0 and 90, give your answer to 1dp, 5 marks. Doesn't look like it's got anything to do with the previous parts. So just write out what it means. 8 cot theta means 8 over tan theta. Subtract 3 tan theta is equal to 2. I've got a tan theta on the denominator. It's not helpful there. Let's multiply everything we see by tan theta to remove this. So I get 8, subtract 3 tan squared theta is equal to 2 tan theta. I would add 3 tan squared theta to both sides and subtract 8. So I would get the equation 0 on the left hand side is 3 tan squared theta plus 2 tan theta, subtract 8. And then we try and factorise if at all possible. 0. We would have 0 is equal to 3 tan theta here, and we want to get ourselves multiplying up to 8. So what we could do is we could say, what about plus 2 here, subtract 4 there. Okay, that would give us the 3 tan squared plus 8 tan plus 6 tan subtract 4 tan is 2 tan, and then subtract 8. Therefore, on the one hand, we would have tan theta is 4/3, or we would have tan theta is -2. Okay, to get theta, take the inverse tan of 4/3, and for this one, for theta, take the inverse tan of -2. Type that on your calculator, keeping your calculator in degrees mode. So inverse tan of 4/3, you're going to get 53.1, so theta is 53.1 degrees. And if you take the inverse tan of -2, you get yourself -63. So theta is -63.4 degrees. Okay, so just drawing out your tan graph. Remember, your tan graph looks something like this. You only care between 0 and 90. 53.1 is going to be the only answer. So therefore, this here is the one you highlight, and this here is the one you say that you ignore. Okay, let's move on to the next question. Have a go, pause the video, I'm going through in 5 seconds. Okay, so we're told we've got this function. We're given that the function can be expressed in Rcos x plus alpha form, where alpha is between 0 and 90, find R and find alpha. Same old stuff again. So we can say that 12 cos x subtract 4 sin x must be equal to R cos x cos alpha subtract R sin x sin alpha. By the same methods we've done previously, we can therefore state that 12 must be R cos alpha, and we can state that 4 must be R sin alpha. So we can state that R is the square root of 4 squared plus 12 squared. So R is the square root of 16 plus 144, which is 4 root 10. If you type that in your calculator, you get 4 root 10. And we can also say that tan alpha is 4 over 12, which is a third, and alpha is therefore the inverse tan of 4 over 12. Inverse tan 4 over 12, keeping your calculator in degrees mode, you get 18.43. Let's keep it to 2 dp. 18.43. So therefore, f of x can be written in this form, can be written as 4 root 10 cos of x plus 18.43 degrees. And we're done, and we got ourselves our nice, easy 4 marks. Okay, let's keep going. Next part. It says, hence solve this equation here. Now, you should notice the hence is the key word using the part previously. We're solving that equation is equal to, that expression is equal to 7 between 0 and 360. Answers to 1 dp. I've got a simpler expression for 12 cos x minus 4 sin x, and it's of the following form: 4 root 10 cos x plus 18.43. So this is equivalent to solving the equation 4 root 10 cos x plus 18.43. 18.43 is equal to 7. I can solve that type of equation. I divide both sides by 4 root 10. Cos of x plus 18.43 is therefore 7 over 4 root 10. I take the inverse cos to get the principal angle, so I take the inverse cos of 7 over 4 root 10. Type that in the calculator in degrees mode, the inverse cos of 7 over 4 root 10, and I get myself the answer 56.40. So I get myself therefore the answer x plus 18.43 is equal to 56.430. So x plus 18.43 is equal to 56.40 degrees. Okay, I'm going between 0 and 360. I'm drawing a cos graph. Just sketch out the cos graph for yourself. You should know the cos graph's looking something like that. 56.4 is here. Let's say 56.4. So another solution, that's 56.4 from a tip. So another solution will be 56.4 back from 360. So the other solution will be 360, take away this, which will be 303.6 degrees. And therefore x, to get x, you subtract 18.43 from both. So you do 56.4, subtract 18.43, you get yourself 37.97, 37.97 degrees. And 303.6 subtract 18.43 is 285.17. And they are your two answers for x. Okay then, and what we'll do next, we'll go into part B. It says write down the minimum value of this. Well, working out the minimum value of this is the same thing as working out, so we're doing C part 1, is the same thing as working out the minimum value, what was it, of 4 root 10 cos x plus 18.43, working out the minimum value of that. And clearly the minimum value of this is where cos of x plus 18.43 is minus 1. So the minimum value of the whole thing is negative 4 root 10. And part 2, it asks you to find to 2 decimal places the smallest positive value of x for which the minimum occurs. I want this to be a minimum, the whole thing, so I'm solving where cos of x plus 18.43 is equal to negative 1. Take the inverse cos of both sides, so x plus 18.43 is equal to the inverse cos of negative 1. So inverse cos of negative 1 is 180. So x plus 18.43 must equal 180 degrees. Okay, just draw your graph, check that's right. It's true, 180 is at minus 1. There's no other places. So therefore x must be 180 subtract 18.43, and working that out, x is therefore equal to 161.57 to 2 dp, 161.57 degrees to 2 decimal places. And there we go, we have the answer. Okay, next question. Off you go, have a go. In 5 seconds I'll go through. Okay, let's do part A. We want to express this here in the form r sine x plus alpha this time. So a slight twist. Alpha between 0 and pi by 2. So as always we write 3 sine x plus 2 cos x is identical to, if we expand out the sine one, it's slightly different. It would be r sine x cos alpha plus r cos x sine alpha. Okay, and that expansion sine a plus b is given in the formula booklet. As always, we compare. We know that 3 must be therefore r cos alpha, and we know that 2 must be equal to r sine alpha. So there are two equations we write down. 3 is equal to r cos alpha, and 2 is equal to r sine alpha. As always, r squared is the square root of 3 squared plus 2 squared, which is r would therefore be equal to the square root of 13. And tan of alpha is 2 over 3, therefore 2 over 3. So alpha is the inverse tan of 2 over 3. Inverse tan 2 over 3. Calculator in radians mode this time. So make sure your calculator's in radians mode, and you get 0.588. So you get alpha is equal to 0.5 let's just do it to 2 dp. So therefore, in the right form, 3 sine x plus, so 3 sine x plus 2 cos x is therefore equal to the square root of 13 sine of x plus 0.59 radians. And you're done. You've got yourself your nice 4 easy marks. Okay, next part. Hence find the greatest value of this. Finding the greatest value, or the maximum value of this, would be equivalent surely to working out the maximum value of square root 13, 3 sine x plus 2 cos x, we know is root 13 sine x plus 0.59. So sine x plus 0.59. So working out the maximum value of that to the power 4 is the same as working out the maximum value of that to the power of 4. Now, root 13 to the power of 4, you could type that in your calculator, but you should be able to work it out, is 169. So this is the same as 169 sine to the power of 4 x plus 0.59 radians. Now, the maximum of this occurs when this is equal to 1. Sine can only be 1 at its biggest, so sine to the 4 can only be 1 at its biggest. So therefore the maximum value, the max value equals 169, and it occurs when sine to the power of 4 x plus 0.59 is equal to 1. Okay, so moving on to part C, we're asked to solve between 0 and 2 pi. This equation here is equal to 1. Now solving that equation is equal to 1 is equivalent to solving the equation root 13 sine of x plus 0.59. 0.59 is equal to 1. Easy to solve. Divide both sides by root 13. So sine x plus 0.59 is equal to 1 over the square root of 13. To get the principal value, x plus 0.59 is therefore equal to the inverse sine of 1 over root 13. Okay, so tap that in your calculator and you would get that x plus 0.59 keeping your calculator in radians mode, of course, is the inverse sine of 1 over the square root of 13, which is 0.281. So we've got ourselves 0.281. Okay, at this stage, draw yourself a little graph just to see all the possible values that you're interested in. Do remember, you're going between 0 and 2 pi, but you're adding 0.59 to your range. Because you're solving x plus 0.59, add that to your range. So the sine graph, or your domain even, the sine graph looks something like that. Okay, I've got one answer here, that's 0.281, let's call it there, 0.281 from 0. So there'll be another answer back here, which will be pi take away 0.281, and there will be another answer over here, which is going to be 2 pi plus 0.281. Okay, so x plus 0.59 will be on the one hand 0.281, on the other hand pi subtract 0.281, which is 2.861, and on the other hand 2 pi plus 0.281, which is 6.564, and then x therefore is when you subtract 0.59 from each of these. So the first one you get yourself negative 0.309, which you ignore because you don't want negative, you want it to be between 0 and 2 pi. This one you do 2.861, subtract 0.59, you get yourself 2.271, 2.271, and the last one you do 6.564, subtract 0.59, and you get yourself 5.974. So 5.974. This is one of your answers, and that is the other answer. They are the two in the range. Okay, next question. Pause, have a go, and then work through my solutions. Okay, let's do this bit by bit. Let's first of all do the first part. It tells you f of x is 5 cos x plus 12 sin x. It says given f of x is in this form, find r and alpha. Same old question as always. So we can state therefore that 5 cos x plus 12 sin x must be equal to, if we expand this out, it must be equal to r cos x cos alpha plus r sin x sin alpha. Do our usual comparison that r cos alpha must be equal to 5 and that 12 must be equal to r sin alpha. Write the two equations that come with that. So 5 is equal to r cos alpha, 12 is equal to r sin alpha. R squared is as always, r is as always the square root of 12 squared plus 5 squared, and r would be 13. And tan alpha is sine over cos, so it's 12 over 5. So alpha is the inverse tan of 12 over 5, making sure your calculator's in radians mode. So inverse tan 12 over 5, you get yourself 1.176. So alpha is 1.176. So in this correct form, you would have it in the form 13 cos of x, subtract 1.176 radians, and you'd be done. Okay, let's keep going. Part B. It says hence solve this equation. Well, obviously we're going to use the hence part. We've got a new expression for 5 cos x plus 12 sin x, and it's 13 cos x subtract 1.176. So this is the same thing as 13 cos x subtract 1.176 radians is equal to 6. Simple equation to solve. divide both sides by 13. Inverse cos both sides to get your principal angle. Tap that in your calculator, keeping your calculator in radians mode. Inverse cos 6 over 13 is equal to 1.091. So x subtract 1.176 is equal to 1.091. Time to draw out a graph here. You're going to draw your cos graph. You're looking between 0 and 2 pi, but because you're subtracting 1.176, you extend your range a little bit as well. So I would just do my range just like that for now. Okay, one of your answers is 1.176. Now you know this point here is pi by 2. You know that point is pi by 2. And pi by 2 in value is 1.57. So therefore 1.091 is somewhere here. Okay, so 1.091. There may be another answer over here. That's 1.091. So there may be another answer here, back 1.091 from 2 pi. And there's going to be another answer here at negative 1.091. Okay, so therefore the different answers we've got, x subtract 1.176 is the following. It's negative 1.091, it's positive 1.091, and it's going to be this value here, which is 2 pi, subtract 1.091, which would be 5.192. Adding 1.176 to everything, x would therefore be equal to x would be equal to 0.085 x would also be equal to 2.267, and the last one would actually be outside the range. 5.192 plus 1.176 would actually be outside, so we would ignore it. So our answers would be this one here and this one here to 3 decimal places. Okay, moving on to the last part, write down the maximum value of this. Well, the maximum value of 5 cos x plus 12 sine x, well surely you can see that that's the same thing as the maximum value of 13 cos x minus 1.176, so 13 cos x subtract 1.176, okay, and clearly that happens when this here, when cos of this here is equal to 1. So the maximum value must be equal to 13. Find the smallest possible value when this occurs. Well, this occurs when cos x subtract 1.176 takes the value 1. Inverse cos both sides, so inverse cos of 1. Keep the calculator in radians mode. The inverse cos of 1 is 0. So x subtract 1.176 is 0. So therefore x is 1.176, and that is the smallest answer that you can get. The next question, have a go at this. Okay, let's do part A. As always, this is the same type of question. We are saying that 4 sine theta subtract 3 cos theta can be written in the following form: r sine theta cos alpha subtract r cos theta sine alpha. That's using the double angle or the addition formula given to us in the formula booklet. Therefore 4 is equal to r cos alpha and 3 is equal to r sine alpha. Write our two equations down. 4 is equal to r cos alpha, 3 is equal to r sine alpha, As always, r will therefore be the square root of 3 squared plus 4 squared, so r is therefore 5, and of course tan alpha will be 3 over 4, so alpha will be the inverse tan of 3/4, and we are in degrees mode this time, so the inverse tan of 3/4 is equal to 36.87 degrees. 36.87 degrees, but to one decimal place, 36.9 degrees. So therefore, you found your r and your alpha. This is in the form 5 sine theta subtract 36.9 degrees. Okay, next part B. We are asked, hence solve that equation. Obviously, hence means use part A. We know an expression for this now, so we're going to solve that expression is equal to 3 instead of this complicated one. So we've got an expression 5 sine theta minus 36.9. So this is the same as 5 sine theta minus 36.9 degrees is equal to 3. Easy to solve. Divide everything through by 5. So we've got ourselves theta subtract 36.9 is equal to 3/5. Just checking that was 36.9. Yes, it was. Therefore, theta minus 36.9 is equal to the inverse sine of 3/5. Tap that in your calculator, keeping your calculator in degrees mode. Inverse sine of 3/5 is 36.87. So theta minus 36.9 will be equal to 36 point, and let's just keep it to 1 dp, 9 here. So let's think of all our values. We're drawing a sine graph between 0 and 360, looks something like that. One of our answers is 36.9, which is here. Another one will be 180 minus 36.9. And there are the only ones in the range. So therefore, one of the answers must be 180 minus 36.9, which is equal to 143.1. So 143.1. Therefore, theta is equal to 36.9 plus 36.9, which is 73.8. So 73.8 degrees. And the other one must be 180 degrees. And we're done. Okay, next part C. Write down the greatest value of I. Well, I know that I, going back to my original equation, is given by this here. So I is also given by 5 sine theta minus 36.9. So I is equal to 5 sine theta minus 36.9 degrees. So therefore the greatest value of I, I'll call it I max, is clearly 5. And that happens in part D. It asks you, when does that happen? Well, that happens when sine of theta minus 36.9 is equal to 1, i.e. when theta minus 36.9 is the inverse sine of 1. Type in your calculator inverse sine of 1. Keeping your calculator in degrees mode, you get 90. So this is 90 here. Theta minus 36.9. So therefore, the sine graph looks like that. One value is 90 here. There are no other values in the range. So therefore, theta is 90 plus 36.9. So theta is equal to 126.9. 126.9 degrees, and we are done there. Okay, next question. Pause, have a go. Okay, working through each part bit by bit. First of all, I want to express this in that form. So I want to say that sine x plus root 3 cos x can be written in this form here, and if I expand that out, that would be r sine x cos alpha plus r cos x sine alpha. Okay, as always, there's a number here that's 1. 1 must be equal to r cos alpha, and root 3 must equal r sine alpha. So 1 must be r cos alpha, and root 3 must be r sine alpha. As always, r is going to be the square root of 1 squared plus root 3 squared, which will be, r will be 2, and clearly tan alpha will be root 3. So therefore alpha is going to be 60 degrees. If you inverse tan root 3 on your calculator, keeping your calculator in degrees mode, you get 60. So therefore sine x plus root 3 cos x is equal to 2 sine of x plus 60 degrees. And we've done the first part. Okay, moving on to part B. Show that this equation can be written in this form here. So it doesn't look like it's anything to do yet with the other part. So we're trying to write the equation sec x plus root 3 cosec x is equal to 4. And we're trying to show it can be written in that form. Probably best thing to do at this stage is simply to write down what sec and cosec means. I.e. this means 1 over cos x plus root 3 over sine x is equal to 4. I don't like cosines and sines on the bottom, so I'm going to multiply everything I see by cos x sine x to remove those off the bottom. If I did that to this, I'd end up with sine x on the top. If I did that to this, I'd end up with root 3 cos x. And if I did this over here, I'd end up with 4 cos x sine x. Okay, well I know from my double angle formulae that 2 cos x sine x, that is defined by an identity to be 2 sine 2x. So therefore, that's defined to be sine 2x. So therefore sine x plus root 3 cos x, I've got 4 cos x sine x, so this must be equal to 2 sine 2x using this over here. The fact that sine 2x is equal to 2 cos 2x, so therefore 4 cos x sine x must be 2 sine 2x. And I'm done. Okay, moving on to part C. Deduce from parts A and B that this can be written in that form there. Now, let's go back to part A and part B. Part A, we found another expression for sine x plus root 3 cos x. Part B, we've shown that this equation with sec can be written like that. I have now got this equation, and I know that this equation here is the same thing. So I could say from part B, sec x plus root 3 cosec x equals 4 is the same as, and what equation did I get? Sine x plus root 3 cos x is 2 sine 2x is the same as sine x plus root 3 cos x is equal to 2 sine 2x. I know from part A that this thing here is equal to 2 sine of x plus 60, and I have that therefore is equal to this from part A, and therefore subtracting 2 sine x, I could divide both sides by 2 first of all, and I could therefore say that sine x plus 60 is equal to sine 2x, and I could subtract sine x plus 60 from both sides and get 0 is sine 2x subtract sine x plus 60. And I've done what is quite a difficult part, although it was only 1 mark. Okay, and lastly, hence using this identity or otherwise, we're going to try and do the hence way. Find the values in the interval 0 to 180 for which this is equal to 4. Now from the part above, I know sec x plus root 3 cosec x equals 4. This thing here is equivalent to this statement here. So I'm actually just going to copy this here. I'm going to just copy this. I know from part C the following. Solving this here is the same as solving that. Now, it also tells me that sine x minus sine y can be done by this formula. We've got here that we've got an x is equal to 2x, and we've got a y, capital Y up here, is equal to x plus 60. Okay, so I know when I'm doing a sine of something, subtract the sine of something else, I can use this formula it's telling me. So what I could work out is x plus y over 2, because I'm going to use that over here. X plus y over 2 would be 2x plus x plus 60 over 2, which would be 3x plus 60 over 2. And x subtract y over 2 would be 2x subtract x subtract 60 over 2, which would be equal to x subtract 60 over 2. Okay, so solving this here, using this up here, is the same thing then as solving 2 cos 3x plus 60 over 2 sine x subtract 60 over 2 is equal to 0. I could divide everything by 2, and these two things are 0. So either cos 3x plus 60 over 2 equals 0, or sine x subtract 60 over 2 is 0. So, therefore 3x plus 60 over 2 is equal to, as a principal value, what we're in degrees, then it must be 90 degrees, or x subtract 60 over 2 must equal 0 degrees. For each of these, draw a little graph for yourself. We're saying here that this is equal to 90. Where is the cos graph equal to 90? The cos graph is, sorry, what has the same value as the 90 there? Well, the 270 does there, so that could also be equal to 270 degrees. And where in the, this came from the sine graph, where in the sine graph are we 0? Well, we're 0 at 0 and at 180, so this one here could be equal to 180 as well. Okay, for each of these, multiply by 2. For this one here, multiply by 2, subtract 60, and then divide by the 3. X is equal to 90 times 2, subtract 60, divided by 3. X is equal to 40 degrees. Then 270 times 2, subtract 60, divided by 3. X is equal to 160 degrees from these two. And from this one over here, what is x equal to? Well, you double it and add 60. So x is equal to 60 degrees. And 180 times 2, add 60. It's outside the range, it's 420. Okay, so we've got three answers, 40, 160 and 60. And at last we're done, and quite a complicated question there. Okay, next question. Okay, going through this one, as always part A is express this in the form Rcos theta minus alpha. This is simple as always, so we have 3 cos theta plus 4 sine theta must be equal to R cos theta sine alpha, cos alpha, subtract R sine theta sine alpha. We can do our usual equations from this. We can state that 3 must be equal to R cos alpha, and we can state that 4 must be equal to sorry, this should have been a plus here. I forgot. Sorry, this should have been a plus. So 4 must be equal to R sine alpha. As always, R is therefore the square root of 3 squared plus 4 squared. So R is going to be the square root of 25, which is 5, and tan alpha is going to be 4 over 3. So alpha is going to be the inverse tan of 4 over 3, and we're in degrees mode, so the inverse tan of 4 over 3 is equal to 53.13. So alpha is 53.13 degrees. So therefore, writing it in this form, it would be 5 cos theta minus 53.13 degrees, and that's it. We've got our 4 easy marks. Next part, part B. Hence find the maximum value of this and the smallest possible positive value of theta for which this occurs. The max must be, therefore, the maximum value of this, of 5 cos theta minus 53.13, and the maximum of that is therefore maximum must be 5, and it occurs where cos theta minus 53.13 has the value 1. So to work out the theta that occurs, you take an inverse cos of 1, so you do inverse cos of 1. Inverse cos of 1 is 0. So theta minus 53.13 is 0. Theta is therefore 53.13 degrees. That is the maximum value at which that is the smallest positive value of theta, where we get the maximum of 5. Part C. It says the temperature f of t is modelled by this equation. F of t is 10 plus 3 cos 15t plus 4 sine 15t, where t is the time and t is the hours from midday between 0 and 24. Calculate the minimum temperature of the warehouse given by this model. Okay, what's this got to do with anything? Well, just look here. 3 cos 15t plus 4 sine 15t. So take a look at that there. Is there anything like we've been dealing with? Yes. 3 cos theta plus 4 sine theta. It's very similar to that. So we can say that f of t is 10, okay, and this, written in the form we had previously, would be 5 cos 3t minus 53.13. 5 cos, 15t minus 53.13. 15t is like theta. I've made the substitution, theta is 15t. And if that's the case, if I put 15t in there, it would be exactly like this. So I can write f of t as that using the work I've done in part B. All I've done here is swap 15t for theta. Okay, because instead of having theta here and theta here, I've got 15t, so I've just put that in instead. Okay? Now, what's the minimum value of this? Well, the minimum value of f of t, the minimum temperature, would therefore be equal to 10 subtract 5. It's the minimum when this is equal to -1. So the minimum temperature must be 5 degrees. Okay, we're asked to find the minimum value of t where this occurs. Let's just think about it. the minimum occurs where cos 15t subtract 53.13 is equal to -1. So we're trying to solve where cos of 15t subtract 53.13 is equal to -1. Okay, easiest thing to do, take the inverse cos of both sides. So 15t subtract 53.13 is the inverse cos of -1. If you do that on your calculator, you get 180 degrees. So 15t subtract 53.13 is equal to 180. And to get t, you simply add 53.1 to both sides, and then you divide by 15. And that will get you your answer for t. So tapping that in the calculator, 180 plus 53.13 divided by 15 is 15.5. So 15.5, and you're done. Okay, next question. Okay, it's a long one, 15 marker. Let's go through it bit by bit. We want to express this in the correct form. So we know that 2 sine theta subtract 1.5 cos theta is going to be equivalent to r sine theta cos alpha subtract r cos theta sine alpha. I could therefore say from that very easily that 2 must equal to r cos alpha, and also 1.5 must equal r sine alpha. Okay, from these two here, r must be the square root of 2 squared plus 1.5 squared. Take the square root of that and you get 2.5, so r is equal to 2.5. And then we know from this also that tan alpha must be 1.5 over 2. We would therefore say that alpha is the inverse tan of 1.5 over 2, making sure your calculator is in radians mode. So change your calculator to radians, inverse tan 1.5 divided by 2, and you get yourself so alpha is equal to 0.6435, and that's to the 4 dp we asked. So writing this out in the right form, it would be 2.5 sine theta subtract 0.6435, and you're done at that point. Okay, to find the maximum value for the next part, the maximum value, all you do is for part B, part I, it's the same thing as the maximum value of this. So the maximum of 2.5 sine, that's 2.5 sine theta minus 0.6435, theta minus 0.6435. Okay, the maximum value of this is clearly 2.5. Where does it occur between 0 and pi? Well, it occurs for part 2, where sine of theta subtract 0.6435 is equal to 1. You take the inverse sine of both sides, theta minus 0.6435 is equal to the inverse sine of 1. So theta subtract 0.6435 must be equal to the inverse sine of 1, which is pi by 2. So therefore theta must be pi by 2 plus 0.6435. And you get for that equals 2.214 to 4 decimal places, that many radians. Next, moving on to part C, it says Tom models the seawater using this complicated formula there. So he models the height of the sea by that equation. T is the number of hours. Calculate the maximum value of H predicted by this value to 2 decimal places and state where the maximum occurs. Well, this here, this bit anyway, 2 sine 4t 4 pi t over 25, subtract 1.5 cos 4 pi t over 25. That looks a little bit like this. Apart from theta is swapped by 4 pi t over 25. Okay, it's the exact same apart from that. So you can, for part C, you can make the substitution theta is equal to 4 pi t over 25, can't you? So therefore the maximum value of this, well, we previously worked out the maximum value of that is 2.5. So the maximum value of h, I'll call it h max, well, it must be the 6 plus 2.5. So it must be 8.5 meters. And for part D, when is it going to be 7 meters? Well, when is the height going to be... oh, sorry, we've got to state where the maximum occurs also in part C. Well, we knew the maximum occurred for theta is 2.214, so this occurs where 4 pi t over 25 is equal to 2.214, 2.214. So solving for t is therefore 2.214 times 25 divided by 4 pi. And you get for that the time is 4.4 hours. Last part, part D, it asks us calculate to the nearest minute where the height is 7. So we're trying to solve when h is equal to 7, i.e. we're trying to solve where 6, we're trying to, I'll just copy this over, 6 plus 2 sine 4 pi t over 25 plus or minus 1.5, so minus 1.5 cos 4 pi t over 25. We're trying to solve where that is equal to 7. So subtract 6 from both sides. We're trying to solve where 2 sine 4 pi t over 25 subtract 1.5 cos 4 pi t over 25 is equal to 1. Okay, we're trying to solve that. Now, I've got an expression for this. This is using the previous work we've done. This is 2.5 sine 4 pi t over 25 minus 0.6 that there. So I'm just going to use this expression here. 1 second. I would have been able to look back up at my work. I think it was 2.5, wasn't it? Okay, I know this here. I can write this as 2.5, sine 4 pi t over 25, subtract 0.6435 is equal to 1. I can divide both sides by 2.5, so sine 4 pi t over 25, subtract 0.6435 is 1 over 2.5. 1 divided by 2.5 is going to be 0.4. I can take inverse sines of both, so 4 pi t over 25, subtract 0.6435 would be the inverse sine of 0.4. And you better do this in radians. Inverse sine of 0.4 you get equal to 0.4115. Now, Okay, therefore, let's draw out our, we're dealing with a sine graph here. Our sine graph looks something as follows. If we had a sine graph here, I know that one answer is 0.41, and there'll be another answer that's pi minus 0.41. So the other answer would be pi subtract 0.4115, which would be equal to 2.73. Okay, therefore I need to find t in each of these cases. For that number, I add on 0.6435 times 25, divide by 4 pi, do the exact same for this. I'll leave you to do that, but you should get so therefore t works out to be equal to 2.1 or t is equal to 6.7. So let's just go back for a moment and let's have a look at what it actually meant. So that was 2.1 or 6.7. So going back to the question, t is the number of hours after midday, and it asks you to work out the times. So it's 2 hours after midday, so it's 14:06, because 2.1 hours is 2 hours and 6 minutes, or it's 6.7 hours after. 0.7 hours is 42 minutes, so that's 6 hours and 42 minutes after 12 o'clock, which would be 18:42. And they're the two times, and you're done. Very difficult question, that one. Okay, last question here. It's a fairly tricky question. It's got a picture. The diagram shows an isosceles triangle ABC, okay, with AB equals AC equals 4, and BAC is 2 theta. The midpoints of ABAC are D and E respectively. You've got all that drawn there. It says show that DE is 4 sine theta. You want to work out this one here. The way I do it, because that's 2 and that's 2 isosceles, you could draw in a right angle there and split that angle in half, exactly in half, and using that therefore as being theta, you could say that you want to work out DE, so let's just work out this one here. You could say that sine theta is opposite x over 2, so therefore x is equal to 2 sine theta, and there you could say that DE is obviously 2 lots of x, because it's that x and another x here. So therefore you could say that DE must be 4 sine theta. And you're done. It says show that P is 8 sine theta plus 4 cos theta. P is this perimeter here. Okay? So clearly in part B then, P must be it must be 4 sine theta plus 4 sine theta, so 4 sine theta plus 4 sine theta, and then it must be plus the lengths, these two lengths, which I'm going to just say 2 lots of the length dg. So the perimeter is 8 sine theta plus 2 lots of the length dg. The question is now, can we work out dg? Let's do a bit of working here. dg, if I know that's theta there, okay, and that's 90, this angle here must be 90 subtract theta. Because that's 90, okay, this angle there must be theta as well, because theta plus 90 minus theta, they're all in a straight line, they have to be 180. So this angle here is theta, hence this side here is 2 cos theta. So P must be 8 sine theta plus 2 cos theta. So P must be 8 sine theta plus 4 cos theta as required. Okay, part C, express P in that form. Remember what P is. P is 8 sine theta plus 4 cos theta. So P is 8 sine theta plus 4 cos theta. And we are saying that is equal certainly to 8 sine theta cos alpha plus, R cos theta sine alpha. So we know from this certainly that 8 is equal to R cos alpha, and we also know that 4 is equal to R sine alpha. We know from these two that R must be the square root of 8 squared plus 4 squared, and that works R out to be as follows. R would be the square root of 64 plus 16, which would be 4 root 5, so R is 4 root 5, and we know also that tan theta, or tan alpha, must be 4 over 8. So in particular, alpha is the inverse tan of 4 over 8. Keeping your calculator in radians mode this time, so alpha would be 0.463. Okay, so therefore, express P in that form. P is therefore 4 root 5 sine theta plus 0.463, and you're done. In the last thing, let's do part D finally. It says, given that P is 8.5, find to 3 significant figures the possible values of theta. So, I have worked this out in the previous part. I've worked out an expression for P being that. I'm told now that P is 8.5. I just have to solve this is equal to 8.5. So, sine theta plus 0.463 must be equal to 8.5 over 4 root 5. Okay, dividing both sides by 4 root 5. So 8.5 divided by 4 root 5 is equal to 0.95, blah blah blah. Actually, there's no need to write that down. You just say that therefore theta plus 0.463 is equal to the inverse sine of 8.5 over 4 root 5. Keeping the calculator in radians mode, so therefore theta plus 0.463 would be equal to 1.254. Okay, what graph are we drawing? We're drawing the sine graph, and I'm going between, it's telling me in the original question, well, we're trying to find theta, and looking back at the original picture, theta is clearly an acute angle, so theta is a small angle there. So we've got an angle here of 1.25. So therefore theta must be 1.254 subtract 0.463, and you get that theta is equal to 0.791 radians. Now previously at this point here, I knew that I should have probably done this. I knew that the angle is 1.254 from 0. Okay, and I know another angle will be pi subtract that. So I know another answer should have been pi subtract 1.254. So I should have really worked out another answer there, which is pi minus 1.254, which is 1.88, 1.888. So therefore there was another answer here when I subtracted 0.463 from that, and I should have got another answer, 1.425 radians. So there were actually two answers for that one there. Okay, that's all for this video. Thank you very much for watching. I hope you found it useful in your revision.